Hello everyone. So let's take a look at this first problem. Let f be the function given by f of x equals x squared plus 4x minus 5. The tangent line to the graph of f at x equals 3 will be used to approximate values of f of x. So in part A, we're going to use the tangent line to approximate f of 4. Now I know we can substitute 4 into the function to get the actual value. I'm using easier numbers so that you can see how this works. We will eventually be using more complicated functions, which will be hard to compute function values, and using the tangent line will be a nice way to approximate values. So the first thing we need is the equation of the tangent line, which means we need an x value, a y value, and the slope. So the x value they gave us is 3. In order to find the matching y value, we have to find f of 3. So if we substitute 3 into f, 3 squared is 9, plus 4 times 3 is 12, minus 5. So that's going to give us 16. Now our slope is the same as the derivative evaluated at 3. So we need to go back over here and find f prime of x. Well, the derivative of x squared is 2x, plus the derivative of 4x is 4, and the derivative of minus 5 is 0. So that means f prime of 3 would be 2 times 3 is 6, plus 4, or our slope is 10. So our tangent line would be y minus the y value is 16 equals our slope times the quantity x minus 3. Now, if we want to approximate the function value for 4 and find f of 4, that's going to be approximately 10 times 4 minus 3. Notice I'm substituting the 4 in for x, but I also have to add the 16 because the 16 has to come to the other side, okay? So if we do this arithmetic, we've got 10 times 1 plus 16. That means that our f of 4 is approximately 26. So far, so good. Now we're going to look at the error resulting when we use this tangent line. So we want to see how different this approximation is from the actual value. And in this case, it's really easy to see because we can easily compute f of 4. But in general, the error that you find from the exact value and the estimate from the tangent line, normally you could just subtract them, but in order to do that, you would have to know which one is bigger, or you simply take the absolute value of the difference. That way you don't have to worry about trying to figure out which one's larger so that when you subtract you get a positive answer. Now, let's actually come up here and find f of 4. Well, 4 squared is 16, plus 4 times 4 is 16, minus 5, so that's going to give us 32 minus 5. That's actually 27. So when we come down here to find our error, the exact value is 27 minus our approximate value that we found before is 26. So that gives us an error of 1. And what that's showing is that when we have this parabola and at this x value 4, okay, if this is where x is 4 and this is where x is 3, the biggest difference we're going to have in here, the distance in here, that's the error. How far the tangent line approximation is from the actual function value, okay? Let's take a look at another one. Okay, for this problem, we have the function f is defined by f of x as x cubed plus 4x minus 1. And a tangent line to the function at x equals 1 is used to approximate the value of f of x, for which interval, when x is greater than or equal to 0, is the error at most 0.4. So we want the error to be no bigger than 0.4, so it can be less than or equal to 0.4. That's where we're headed, okay? So the first thing is we need to find our tangent line. So we're going to need an x value, which they told us is 1. The y value, we find f of 1, which would be 1 cubed is 1, plus 4 times 1 is 4, minus 1, so our y value is 4. Our slope, we find by evaluating the derivative of f at 1, so we need to come back up here. Let's find the derivative of f of x. The derivative of x cubed is 3x squared, plus the derivative of 4x is 4, and the derivative of -1 is 0. So f prime of x is 3x squared plus 4. Now, if we substitute the 1 into the derivative, we'd have 3 times 1 squared, or 3, plus 4, which means that our slope is 7. So now our tangent line, y minus the y value of 4, equals our slope 7 times x minus the x value of 1. Now what I'm going to do for this problem is I'm going to bring over that 4. So it's 7 times the quantity x minus 1 plus 4. Now this is a calculator question for a reason. Notice all the choices are decimals. Gives you a little hint as to why. So we're going to go to the calculator because remember, what we need for the error is we need the function value, which is x cubed plus 4x minus 1, minus, right, this is the function, the actual value, minus the estimate value, that's the tangent line. So that would be our 7 times the quantity x minus 1 plus 4, and we need this in absolute value. We wanted that error to be at most 4, so this is going to be less than or equal to 0.4. So in our calculator, we're going to put a few things. We obviously need the function. So let's say in f1 of x, we're going to put the function, which is x cubed plus 4x minus 1. And I'm going to label that function. That way, when you look back, you'll be able to do this with a different function and tangent line. In f2 of x, we're going to put that tangent line, 7 times the quantity x minus 1 plus 4. That's our tangent line. Then, because I really don't need those two graphs, I'm going to change to a different page. And in f3 of x, we're going to put that error function, the absolute value of the function minus the error. Now, in all honesty, since we're in absolute values, it does not matter which order you have that in. You can reverse and do f2 of x minus f1 of x, does not matter, but this is how we find the error. Then in f4 of x, we're going to put that 0.04 that we want our error to be less than. Okay, so that's the max error that we want. And then we're going to find the points of intersection. So let's go to our calculators. So we're going to open a graph page. Let me get my calculator over here. In f1, we said we're putting the original function, which is x raised to the third, get out of my exponent, plus 4x minus 1. I'm going to arrow down. Then in f2, we were putting our tangent line, which is 7 times the quantity, x minus 1, close the parentheses, plus 4, and I'll hit enter. Again, I'm not worried about what those graphs look like, so I'm going to add a page, Control Doc, make it a graph page, so 2. Now here in F3, I'm going to go to my template key. We're going to get that absolute value at the top right, absolute value, and we're going to put F1 of x, close it, minus f2 of x. I'm going to arrow down, and then our maximum error was 0.4, and we press enter. Now, we were also told in the problem that we were using a domain where x is greater than 0, so I'm going to change my window here. And whether or not you change the 10 as a max, that's up to you, but I want to be able to see my graph. Now notice this black curve is the error curve, and at the left end it's above that maximum error 0.5, and at the right end it's also above that maximum error. So when the error is below 0.4, which is in between those two intersection points, I'm going to go to menu. I'm going to choose 8 for geometry, 1 for points and lines, and 4 for intersection points. I'll click on my error, click on my max error, hit escape to get out of that. And now I can see that from the values where the x is 0.608 to 1.35, but that only has 2 digits after the decimal, so we point at it, control menu, attributes, bring that up to 4 digits, then you can go back to 3 digits, and there we go, 1.346. So between the x values of 0.608 and 1.346. So based on what we saw with the calculator, our answer should be choice A. One more problem to look at together today. We're going to let g be a differentiable function such that g of 3 is 2, g prime of 3 is negative 3/4, and the graph of g is concave down on the interval from 2 to 4. Which of the following is true about the approximation of g of 2.6 found using the line tangent to the graph of g at x equals 3? Well, first thing is, every one of these choices has a value, an approximate value for g of 2.6. So we need to find the approximation. So first thing, let's find the tangent line. The x value we're given is 3. The y value is g of 3, which they told us is 2. The slope is g prime of 3, which they told us is negative 3/4. That means that our tangent line would be y minus the y value of 2 equals the slope negative 3/4 times x minus the x value of 3. Now, you might want to move the 2 now or in the next step. That's up to you, but it eventually has to come to the other side here. And I'm going to go like this. Now I'm going to approximate g of 2.6 is approximately negative 3/4 times our x now is 2.6 minus the x value 3 plus 2. So if we do a little arithmetic here, it's negative 3/4 times negative 0.4 plus 2. Now notice, this is on a non-calculator part, but 4 goes into negative 0.4 very easily. They will usually give you nice numbers to work with. That's going to give you a negative 0.1. So when you multiply by 3, it's a negative 3. It's just a positive 0.3 plus 2. So we now know that g of 2.6 is approximately 2.3. So that's the first part of our answer, which means we've eliminated A and we've eliminated B. Now the next part they talk about is whether this tangent line is an overestimate or an underestimate. Now remember, all curves come as one of these pieces. Those 4 pieces of a circle represent all possible curves. Notice 2 of them are concave up, 2 of them are concave down. If you were to draw the matching tangent lines, whoop, 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 and I know this is not perfect, whoop, notice when the curves are concave up, the tangent lines are underneath the curve. These are underestimates. When the tangent lines are above the curve, those are, and that's when the curves were concave down, these are overestimates. And we were told in the directions that G is concave down, which means we are in this one of these 2 cases, which means the tangent line is above and we have an overestimate, which means choice C is our answer. Okay, guys, have a great day.